years old and only cost me €250, but it still works. It's just not so super fast. There we go. Presentation. Okay, so if you can write this down, the vector triangle. So again, not so difficult, unlike Friday's lesson. Okay, continue, you got that? The vector triangle. Yeah. So, what are we going to have a look at? We're going to talk about how to add vectors together, basically, is the key idea of the lesson. So, vectors can be added together by using what's called a vector triangle. This is how we can add two vectors together. So, let's take two vectors, A and B, and I want to add A and B together. How can I do that? Well, firstly, some vocabulary. When you add vector A and vector B together, the answer is called the resultant vector. Okay, so A plus B, the answer is called the resultant. You should write that word down, resultant vector. It means the total when you add two vectors together. Is this a new word, or do some people know this one? Familiar with it, yeah? I mean, it makes sense because you know in English the word result means answer. So, it kind of makes sense. Now, or can be shown below. So this is how you add two vectors together, okay? If you have A and you have B, what you do is you put the tail of B at the head of A, and the answer then is this vector here. Okay, so that is, to add two vectors you must put the tail of one vector at the head of the other, and then the resultant is from the tail of A to the head of B. Okay, so this is called the vector triangle. It's how you can add two vectors together. Now just before you draw that, let me just point out, if you had two vectors here, A, and let's say one is here, B, what you need to do is you need to move this. But when you move it, don't change the length and don't change the direction. So it would look like this. Yeah. So then A plus B is this one here. Okay. So if you can draw this, please, that would be great. Who has seen this before? Have you seen this triangle before? Yeah. Now there is another way to add them together. I wonder if anyone knows. There's another method for adding using a different shape. Anyone know? Parallelogram?
Yeah, it's the one you can like
yeah.
cross and then you press the point.
Yeah, it's like it's kind of like a rectangle, isn't it? Yeah. Okay, continue. You drew this? Yeah? Okay. So, we can multiply. Okay, so firstly, we've learned how to add two vectors. Great. What we can also do is take a vector and multiply it by a scalar. So what exactly does that look like? So maybe somebody knows this. If I was to take a vector and multiply it by the number 2, what happens to the vector? So if let me draw that. If I have a vector,
doubles.
That's it, yeah. If I have a vector, let's call it or, and I multiply it by 2, then it's, as you say, doubled. Okay, so when a vector is multiplied by a number such as 2, as an example, it will double in length. What happens if I multiply it by a half? Well, then it halves in length, yeah. There's a half or. Okay. What about if I multiply by minus 1?
Goes other direction.
Not disappears.
It goes other direction, opposite direction.
Yeah, so like this vector here, that's minus r. Okay. So it flips it around 180 degrees. You know what might be good? If you draw these down as some examples. So or 2 or a half or and minus or. I think it'd be good if you can draw that. You can make yours look a little nicer. Okay, got that? Yeah. By the way, Simba. Did I get it right? Anyways, how would I make a vector disappear? So it's not quite multiplying by minus that makes it disappear, but I could multiply by something that would make it disappear. Do you know what?
0?
Yeah, that's it. If you multiply by 0, it vanishes. Okay, right. So we can add, subtract, multiply and divide scalars. You learn how to do this in elementary school, 2 plus 2, 2 minus 2, that's easy. We can multiply a vector by a scalar. We can add or subtract vectors. But what we can't, this is what we can do. What we can't do is multiply two vectors. Well, we kind of can, but that's more for math class. So right now we can't really multiply vectors, okay? We can add vectors. We can even subtract vectors. How would you subtract vectors? So suppose I want to do A minus B. Well, you realize, oh, well, that's just A plus minus B. So, if this is A and that's B, well then this is A and that's minus B. So A plus minus B would be this, wouldn't it? Yeah. So you can also minus the vectors. Yeah. So what can we do with vectors? We can add them, we can subtract them, but we can't multiply or divide them. And what can we do with scalars? Well, you know what you can do with scalars. You can do everything with scalars. And what about if we want to mix them? Yeah, we can mix these two, can't we? Because you could have something like A times A plus B times B. So an example, you could have 2A minus 3B. That'd be okay, wouldn't it? Yeah. This is what we can't do is this. If we have two vectors. So we can't do that. And we cannot divide either, like I said. Okay. Whoops. Let's have a look at an example. We will do this one together, but I just want you to write the question down, okay? And we'll do it together. Okay. Let's have a think about this. So I think the first one is no problem, isn't it? Draw the two vectors, 5 kilometers east and 5 kilometers per hour to the north. I think we can all do that, no trouble. So let's have a look at that. So let's all draw that together. Here we go. This is vector A, and then what's vector B? 5 kilometers to the north. So think about what I'm doing. Let me just draw it here. This is vector B. There we go. Vector A, vector B. They should be the same length, right? Roughly. Okay, so that's part A done. Part B. Can these vectors be added together? What do we think, class? Yes or no? Ah, wonderful. I love it when all my students are wrong. They can't be added together, but who can tell me why not? No, that's not the problem. Different units. I see, I tricked you, didn't I? One of them is kilometers, and the other one is kilometers per hour. So technically we can't add them, because we learned in the first lesson they have to have the same units. They don't. Kilometers per hour. So the answer for the second one is no, because they are different units. See. Okay, C. Consider the vector TB, where t is 2 hours. What is the dimension of TB? So, TB, what is the dimension? Remember, we can represent dimension like that.
L.
Yeah, it is, isn't it? Because what's the dimension of T? Time. And dimension of B? B? Length per time. Length per time. So the dimension of TB is length. This is what we did in the last class, talking about this. So, the next question is, draw TB. What would TB look like? What would TB look like? Well, there's B, and what's T? T is 2, so what would 2B look like? Double, yeah, so this would be TB, because T is 2. Okay, so that's TB. Right, D. Draw, oh, sorry, that was D. E. E. Draw the resultant of A plus TB. Now, can we add A and TB?
Yes.
Yeah, why? Same unit. They're both kilometers. They're both length. Okay. So I want to add A and TB. So let me just move this guy over here. No, what am I saying? I should put it here. There you go. There's A. There's TB. So here we go. That is the vector A plus the resultant A plus TB. That is part E. Is that okay? Now the last part for you all to think about is what does this vector or equals a plus tb, what does it represent?
Resultant vector.
Yeah, but like I suppose in the story, you know, if you look at what A is, look at what B is, look at what T is, what do you think the story is? What do you think is happening? Oh, nice, but no.
Hypotenuse?
No, you're thinking too mathematical. I want you to think about what these vectors could represent. And so what could or represent?
The displacement.
Yeah? You're making it very complicated, very complicated. Vector or is 5 kilometers east. Vector B is, what do we say, 5 kilometers per hour north. And vector or is A plus TB. So what could A, B, TB, or what could they all represent if we were to try and put a story on it?
Direction?
A story. Like, you know what I mean? Like, tell me what each one could represent. No.
Do you think it?
No imagination, no storytelling power, is it? Okay, look, A is 5 kilometers east. So what type of vector is that? What's that called? It's a displacement. Okay? So we're saying there is something 5 kilometers east. Yeah? Now, B is kilometers per hour. So what does kilometers per hour represent? Speed. But because it's a vector, it's a velocity. Okay? Now, if we multiply 5 kilometers per hour by 2, that's 10 kilometers distance. So what do you think that represents? Something that has moved for 2 hours at 5 kilometers per hour. It's travelled 10 kilometers, yeah? So A plus TB. So what you're saying is in the story, there is something 5 kilometers to the east. It is heading 5 kilometers per hour north. It does this for 2 hours and it finishes up here. So the resultant vector is where the thing is after 2 hours. So the story is start at A, head in B for 2 hours, finish at or. Now, it's not a wonderful story. You know, nobody's going to make a movie out of this, but I hope you all understand this story. Oh, sorry. I said end, but I wrote end, but I said head. Head in B. Move in B. You don't look happy with this. Not happy? No. What's confusing here?
I don't get it.
The story? Yeah. If we go back, the question said A is 5 kilometers east. So that's a displacement because I'm telling you where something is. So that's start at A. B is a velocity because it's 5 kilometers per hour north. So that's why I said head in B. It means travel north 5 kilometers per hour for 2 hours. So if this is where you start and this is where you move, then when you add them together, that's where you finish. Okay, so it's a little story like this. Continue. Yeah, is this okay, Ken? Yeah. You also don't look happy with this. Is okay? Yeah? Alright. Now, what I'll do, I will let you try this one by yourself and then I'll do the answer. Okay? A little bit harder, but I think, yeah, there's just one thing left. Just one thing left after this. So, I'll let you try this for a minute, see if you can get the answer. This is This is like an exam question. This type of question in the exam is kind of like this. Okay, so let's see if you can do it yourself. What's so funny? Huh? Surely there's nothing in this so funny. Is there a typo or something?
No.
So what's so funny about this?
Nothing.
No? Are you thinking of dirty jokes or something? Like what? No?
Journey.
No? Do we think we know how to do some of these? How's that going, George? Which part are you on?
Okay.
Yeah. What was the formula for speed?
Distance over time.
Yeah, so what's the distance he travelled? Yeah. Go on.
Plus 5.
Yeah.
Plus 1 plus 1.
Yeah. So he's travelled 12 steps
Mm-hmm.
in 9 seconds.
So 12 over 9.
So 12 over 9 steps per second.
4 over 2.
Yep. Will we do this one now? Is it a bit confusing? Did you get the first part?
Yeah.
Yeah. Will we do this one together? Did you get this, Kim? Yeah? Great. All 4 parts? A, B, C, D, E? Which part are you on? D. Okay, great. Maybe we'll do this together. So, what was his speed? Well, the speed is the distance he travelled, which is 12 steps, and he did that in 9 seconds. So the answer is 1.33 steps per second. Is that okay? Is that okay? Yeah. All right. Now we have to draw. So let me just make this a little bit nicer by just making a grid. You know what I'm trying to do. So, a man walks 5 steps north. 1, 2, 3, 4, 5. Okay, so this is the draw the 4 velocity vectors. Yeah. So this one here is I'm not happy with that word. Anyways, it doesn't matter. 5 steps north. Flip. 5 steps north. 5 steps west. 1 step east. And 1 step south. Okay, so they're the. I do? Oh, the width, sorry. I know what you mean. I did 6, didn't I? 5 steps north. 1, 2, 3, 4. 5 steps west. 1 step east. And 1 step south. Yeah, okay. Draw the displacement vectors. Okay, so. Displacement vectors now. First, he's here. Then, after he travels north, he's here. Then, he is here. Then, his displacement is here. And then, finally, his displacement, is here. So the displacement points to where he is. So first he's there, then he's there, then he's there, then he's there. So they're the displacement vectors. It's a little messy to draw. Okay. Now, this is interesting. What is the magnitude and direction of his final displacement? So the final one is, we said, I'll put it in green. Well, maybe green's not the best. I'll put it in red. This is the final displacement. He finishes there. Okay, now, what's the magnitude? Well, that's the length of this. What is the length? Well, it looks like it's roughly 1, 2, 3, 4 boxes, doesn't it? But it's not exact. In fact, if I draw a little triangle here, this is exactly 4 boxes. This one here is exactly 4 boxes. And I give you a little clue. I say when you have a triangle with 4 and 4, The longest side is 5.65. So actually this here is 5.65 steps. And I also tell you that this angle is oh, I don't tell you this angle. You'll have to, oh well, you know what this angle is. If this is 4 and this is 4, then what's this angle?
90. No, like that's 90 and that should be 45.
Yeah, that should be 45, because these are both 4 and 4. So the answer is 5.65 steps at northwest. It's exactly northwest, isn't it? That's the displacement at the end. Is that okay? Are you sure? Last part? Last part? What is his average, what's his velocity? Alright, so what's his velocity here? You see, that's not the same thing as the speed. What did we get for speed? I think we said speed is, there it is, 1.33 steps per second. Is that his velocity? No. No. What's his velocity? Yes. And something else. You've given me half the answer. You are correct though.
5.65 minus 1.
Minus, no, no need for minus. He missed something from his answer. He said 5.65 divided by 9 is what you said. But you've missed something. There's something else too.
The unit.
Well, the units of course, yeah, but something else.
Direction.
Yeah. Yeah. Remember it's velocity. So velocity is displacement over time. Yes, you have the formula? Displacement over time. So what is the displacement? The displacement is 5.65 steps northwest over time. And what's the time? 9 seconds. What's 5.65 divided by 9, please? 0.63. 6.
No, 0.627.
Oh, 0.627 steps per second northwest. Oh, Kim, you look very unhappy with this. Have you got a question? Are you sure? Okay. I don't know if I believe you, but okay. And you also look unhappy with this.
And I think I've studied before, but that's a long time ago.
How long ago?
10 years.
It's a long time ago. Yeah.
So I needed time to
Remember, yes. Yeah. No problem. This will be on YouTube later, so you can watch it again if you like. Yeah. Yeah, go ahead, yeah.
Is the closest one in the continuum?
Unfortunately, yes, that's the closest one. It's very strange that there's not one in this building. Can you get by?
Yeah.
Yep, okay. Right, is this question okay? Can I continue? Yeah, sure, yeah. Is this one okay for you? Yeah. You get that the only thing you missed was the direction, yeah. You see, it's painful because in the exam that's the type of thing that will cost you 1 mark. You know, yeah. Which part are you writing down?
7.
Yeah. Okay? So the last thing here, if you have two vectors A and B, we can say that vector addition is commutative. What that means is A plus B is the same as B plus A. It doesn't matter which way around you do it. That's all I wanted to say at the end there. So if you do A plus B or B plus A, you get the same answer. So maybe you want to write this word down. This word commutative means this relationship. Commutative. You can just write down A plus B equals B plus A and write beside that the word commutative. Okay. You got that? Yeah? Continue? Yeah? Okay. So, I think that's all I wanted to do with those vectors there. So, you have some questions. Now, because we didn't take a break, we'll finish at 12:40. So, you have 20 minutes. I think you could get all these done in 20 minutes. So, if you get them all finished, then there's no physics homework. Okay? I don't think that would be a problem. So, if you can try and do these questions now in the vector triangle.